the WAN using something called DPF. Okay. So the relevant problem here is we have a site with separate file servers that are very geographically far apart, and in the network connection between them, the latency is relatively high. I don't have exact numbers, but just sometimes you have machines that are right next to each other in the rack or in the same room. Sometimes you have machines that are across countries, across different continents. This leads to slow operation with RX, both because of it's because of both intrinsic problems and just problems that are fixable. So I'm sure the performance is improvable with RX. But there are theoretical limitations related to the window size. So the current window size in the code base uses 32 packets, and assuming our packets have about 1389 bytes of payload in each packet, then the maximum throughput that you can hope to achieve with a 10 millisecond RTT is around 4 megabytes. And if you raise that to 255 packets, which is the maximum that the ARCH protocol currently allows, you can get up to 33 megabytes per second. Depending on your setup, you may find this limiting or not, but it's certainly much lower than the limits you would get with TCP window scaling. So I've talked a little bit about this in previous years at the European workshops. If you want to search for it, those should be the titles of the presentations. So I'm not going to be talking too much about the protocol design and development side of things. This is more about administrative operations, just how the feature kind of looks. But those are the problems we're dealing with. So if you do a volume release with two file servers that are, say, 100 milliseconds apart, then you can have also a factor of 10 with the theoretical limit on the throughput. So DPF is this thing, stands for Disposable Protocol Framework. It's not really it's not one little feature. It's a framework that we use to kind of develop changes to the protocol in a kind of modular way. So it's a general purpose kind of protocol capabilities negotiation. It encourages, or one of the goals is to allow for rapid development of different protocols. So we don't need to probe so much, if we have different RPC numbers, you need to keep calling RPC numbers, see what the other side supports until you get something that works. So we try to avoid that with some capability negotiation. And most people associate this in the context in which I've talked about this in previous talks is always with TCP, how we get TCP, how to leverage TCP and existing RX connections. But it's not specific to TCP. The current set of features that we currently support are, TCP is still one of them, but we also do on-the-fly compression using LZ4 and TLS encryption. This is deployed in production. The thing I'm talking about here is this version of it is deployed in production at one site in a 1.6, a modified 1.6 to support this, specifically for the vol server service. There's also another site that runs a previous iteration of this general idea, but it's a different version of it, which we're going to be at some point migrating off of that to this new framework. So from the administrator's point of view, the UI you get are some new flags to VOS release, VOS dump and restore, and anything that uses dump and restore internally. So releases, moves, copies. Also VOS shadow, which uses that, so bother. So to turn on DPF in general, you can press -DPF to basically turn it off, to make sure it's off and force it off. You say no DPF. And if you want to specify specifically which capabilities, which plugins you're using, there's another option to specify what we call a pipeline. We'll get to that in a second, what that looks like. The volume server itself has some options to turn on or off the functionality. So this was, at least at this site, this was so we could give them a new version, so they would have the binaries, and of course if they're broke, then it's easy to just turn it off. You don't have to replace the binaries and roll them back or anything like that. That last option there, called S2S DPF default on, is a way that we can allow releases and moves to use this new functionality without the VOS command really even needing to turn it on, or the VOS command even needing to be running this new code at all. Because those operations the operations like releasing and moving and copying volumes, they happen as a direct vol server to vol server connection. So the vol server itself can turn that on without you having to specify it in the FOSS command. So the way that pipelines work, you're specifying here we are specifying specific plugin names, specific modules. In the first example, that's using just TCP basically. The other two modules, the first is an EOF detection module, which we need for TCP but do not for RX, and a fcrypt is so it's something to apply similar security guarantees as the existing OpenAFS RX connections, RxCat based. So it's fcrypt based, so it's not good. But this is what you get when you don't have OpenSSL support compiled in. And the second example is using compression just over a regular RX connection. So yeah, you can get some of these benefits just using regular RX as well. One thing that we noticed when we deployed it at this site was normally when you issue a VOS status, you can see how far along a release is or a move or whatnot by looking at these counters. This is not, I'm sure this is not the original purpose of these, but because it's the only way to get any progress, people over the years have used those counters to see how far along we are, how much data we have sent. So this site and a lot of other sites, you take the number of packets that you have read on the restore side, multiply it by 1389, and you say this is how many packets we've done in the transfer. For DPF connections, we don't go over the normal RX connection, well, if we're transferring over TCP. So what they saw was this counter would always stay at 2 or 1 or what have you. So they didn't get any progress information. So one of the changes we made to this was to emulate those packet counters. So in DPF we know what the actual transfer count is, of course. So we just look at how many bytes we've transferred, and we divide it by 1389 to provide those packet counters. So of course we discussed, or I considered having a different way of reporting this that would be better, so you can see the actual packet count, or it's like the actual byte count, not packets. You don't have to translate from packets. Or maybe a new interface that would provide more information, but for now I haven't really done that. This allows people to use it without having to update their scripts. There's no migration or anything like that. But at some point, having something for better status reporting of these would be nice. So just an example of one of the volumes that they told me about. If you had a 1 gigabyte volume that you needed to release, 2 of the file servers were in different countries, like on the opposite ends of Europe. And previously when he was running these releases, I'm assuming all the 1 gigabyte data changed, or it was releasing to a new set of the file server. It took over 20 minutes, and at that rate, it's less than a megabyte per second. And the code they're running now, which uses TCP and compression, it's down to about 1 minute. I don't know what the RTT is between these machines, and I don't know much about the data, so I don't know how much is compressible versus not. I also don't have, I haven't been really benchmarking this myself. There's usually not a lot of tuning involved. This is more of an exercise to kind of port the transport to another technology and just kind of see what happens. So one of the problems that I had, so one of the things I don't like about this is the specifying those pipeline specs is really awful. It's really cumbersome. I use some shell variables to kind of make it shorter so it actually fit on a slide. But normally when you do that, it's like one big string. It's like too much characters long. So right now, that's the only way to actually to specify if you want to use compression or turn off compression or what have you. Most of the time, I imagine people would just use the defaults and just we try to make reasonable defaults to make things go faster. But of course, it would be nice to be able to specify which ones you may want to turn them on or off. So you may have a volume that's is very compressible, or you may have a class of volumes, like types of volumes. You have some volumes that contain application data and some volumes that contain configuration data. And the configuration data, if it's full of YAML files or something like that, or XML files, they probably compress really well. So you may want to turn these on and off. So an idea of trying to make this simpler, none of these are implemented, these are just ideas. We could keep the same kind of syntax, so the models are separated by colons. but maybe we could have like shorter aliases, so it's a little more reasonable. It still looks a little funny, but if you know what those mean, it's pretty concise and fairly intuitive for what those different things mean. Or we could just extend we could add more command line flags to all the various commands. So right now, encrypt is already one that we have, and it's used for whatever, like theoretically, whatever security class we'll be using that will force encryption to be turned on. So we could use it for this too, and we could add similar options to just say like compress, and these could have like no variants. We say compress, no compress, and another one for TCP. So even if we do something else with some other scheme outside of using this DPF stuff, it doesn't reference DPF. So it's, that's really that's more direct, that's more real. I feel like that's more accurate for what the user is really requesting. They don't care about all this technology, all this other crap about, all this other stuff about how we're implementing it. That's really implementation details. So that seems like a better way. It's a little more annoying to implement because we have all these different utilities. You got to add the command line options to them. But we really probably should improve that, like have a way of having a better way of having common flags between things. Because right now, you kind of need to specify them separately.
You think there's something you could do in a configuration file?
Yeah, so that's the other thing. The reason that these are such long strings is because the intention was this would be specified in a config file somewhere. You can say which you'd like specify another directory of like loading modules, and here's the string one, use these modules and these transfers. Because the current the site where this is deployed is 1.6 based.
We don't have what the config directory.
So and even in master and 1.8, it's not like there's support there. I'm not sure. I haven't tried to use it with something like this, but like having hooks to like add new configuration directories or something like that. I'm not sure if all the support is there, how convenient that is, and of course people aren't used to using the configuration files yet. But of course that can change. And I also want to be able to specify, and so these need to be specified like per command that we run. So maybe like aliases maybe could be specified in the command line, or you could have like groups of options or something specified in configuration files to say like the dash and crush option means you specify these other options or something like that. There's a few ways, I'm not quite sure how we're going to do that. So like I said, this is just running. It's running in production on site, and they seem to be pretty happy with it. It's running for. It was running in a kind of testing capacity in a certain subset of volumes. I think Mike, you maybe said that it's turned on for everything now.
I don't know. I thought it was just a subset, but it could be all the volumes.
Okay. I'm not sure. One of the things we want to do, or one of the things that I really haven't done is done any optimization at all. Some of it is really quite ridiculous how it's not optimized. In our so since this is for volume operations, we're dealing with volume dumps, and anybody who's looked at the volume dump code knows that our format is like tag value based. So for a vnode, we'll dump a 4-byte tag saying the next thing is the vnode is like the unique fire number, and another one. So you have 4 bytes and 4 bytes for the number, 4 bytes for the tag for the owner, and 4 bytes to actually say what the owner value is. And so all those are written, you write 4 bytes and 4 bytes, 4 bytes, 4 bytes, and then 4 bytes, 8 bytes, and then you write like a gigabyte of data for the actual file data. And currently there's no buffering in the code. So that means if you're using compression, you write 4 bytes, and then we try to compress those 4 bytes, and then we flush it to the TCP stream. So it looks, so it's really stupid. But so when you have enough data, when you have, like for reasonable volumes, most of the data is the file payloads, and that's the thing that we compress more reasonably, and that gets shipped on the wire a little more reasonably. So that's why it still provides a lot of benefit. So I haven't really done retuning, and certainly haven't done like benchmarking or anything like that in like high CPU usage situations. So that's really something I want to look at. I also want to port this to other services. So this is being used for volume operations right now. Some people really want to see this for client file server communication. The reason that volume operations were chosen for this as trying to be the first thing that we do is that those are, the protocols for that are considered more, like slightly more internal because they're administrative operations. So the client file server interface is much more important in terms of compatibility and being sure that we're doing the right thing and all that, because you may not, obviously you may not control your clients. Anybody can have a client and do whatever they want. So at some point, we need to be thinking about standards. I don't know to what degree we are still kind of sticking by the existing, like the standards procedure. I haven't written an RFC style document for this yet. And I wasn't sure like how much that's required for some of the internal side, like the administrative side of things. So I need to figure that out, how exactly we're going to do that. If we get if we do that and get everything in a row and people are on board, the earliest target we would see for this in the release would be the 1.9 series. So I don't know if that's going to happen, or if we get to it later, but that's the directions we're going in right now. So unfortunately, I don't have code to share, which I try not to say coming soon. Like I really want to have a link up there. The current implementations of this are all for customer-specific tailored versions, and they're all based on 1.6. So I don't have a version that's ported to master, but that is the next thing I'll be working on. That's another direction I'll be going. So if somebody wants to use this or try it out, I could give you something based on 1.6 that's very has a lot of caveats on it. But it's probably more worthwhile to just wait for something that hits master and be closer to 1.8. So that's on me. Yeah, so slides are there. Any comments?
Slides are coming soon.
Yeah, the slides are right here. Yes.
Is there any sort of thought put into sort of freak cases where, like, say you have a plant that's set up and you perhaps don't have all of the cells running the version that supports DPF?
Yes. So,
or also cases where maybe you have a cell that's behind a DMZ or behind firewalls, and maybe you don't have that particular port of it. Can it fail back to or fall back to the conventional?
Yeah. So Paul's asking about if one piece of it doesn't support DPF, do we fail back? And yes. So if something doesn't have it supported and or it's not turned on, then yes, of course, we fall back to the regular ones. So the port not being open, I believe we do, but it's not. I mean, honestly, it's not a case that I've thought too much about. I believe if the DPF transfer fails, I might be thinking about a different version. That might be the client file server bit. But the way that I intended was that if it fails for pretty much any reason, then we try, or if it fails for any reason, like before a certain point, we would retry with the old way, the existing way. That's the idea anyway. I don't know if that's implemented right now, but that's the plan.